Alright, kule video le ngifuna sibheke i-concept ye-Faraday's law la ku-electromagnetism. So ngifuna sibheke ukuthi le formula leli bali-derive kanjani, right? Or in terms of i-setup ungali-explaina kanjani le formula leli Faraday's law, right? So all in all la ku-Faraday's law or ku-electromagnetism sizama ukuproducer ugesi. So we're trying to produce electricity. Right? So we need electrical energy. But this electricity or this electrical energy is we use what we call mechanical energy. So it's from mechanical energy. This is totally mechanical energy, let's say converter. As a converter is the electrical energy. Right, so what is mechanical energy? Mechanical energy, it's all about a movement, right? Kinetic energy and potential energy. So that is the sum of kinetic energy and potential energy. That is your mechanical energy. So there must be movement, and then that movement is converted to electrical energy. But setup your core. But then all in all, we are trying to produce electricity, right? Okay, so asibheke i-setup engasiza ukuthi si-explain le concept le ye-Faraday's law. So nasibheka i-setup yethu, the first thing eba khona la ama-magnet, right? So mhlambe nangasama ukwa-draw in 3D sizothi sinama-magnet kanje. Right, okay, le magnet yokuqala, and then we have another magnet there, then the magnet has 2, right? And lama magnet lawo anama poles lawa different. So this is the first thing we wanna like, let's set up here Faraday's law. You have a magnet with the north pole and you have a magnet with the south pole, right? So if sisebenzisa lama magnets way 2, which is the north and the south, in between lama magnets there is what we call a magnetic field, right? And this magnetic field results due to the presence of these magnets, right? Okay, so the magnetic fields, they're not visible, right? But we can use these lines to represent this magnetic field, right? And lama line lawo esiwasebenzisayo we call them magnetic field lines, right? So it's representa ukuthi between the north pole and the south pole of a magnet there is what we call a magnetic field, right? But the magnetic field asikwazi ukuyibona with our naked eyes, but we can represent it on paper using magnetic field lines, right? But lama magnetic field lines, direction yawo, they move from north to south, right? So if I were to indicate a direction la, whether they move from north to south, so a direction base of kanje, right? Okay, so this is the first thing esifaka ku setup yethu. Sifaka ama magnets way 2 and in between sifuna ukudevelopa le magnetic field kahle la, right? But the magnetic field kumele ibe strong kahle kahle between lama magnets way-2, right? And singayenza njani ukuthi le magnetic field ibe strong sisebenzisa ama-magnet lawa strong, right? It means if sisebenzisa ama-magnet lawa weak, it means the magnetic field yakhona izoba weak at the end, right? But to achieve EMF a high, or to achieve ugesi omningi esiproducayo la, mele simake sure ukuthi lama magnetic field lawa they are very very strong. So we ensure that by using stronger magnets, right? Okay, so how do we actually generate ugesi using this setup? Sithatha i-coil, right? Okay, before siya lapho ku-coil, as explain the strength salama magnetic field. So for example, if magnetic field strength, so the magnetic field strength depend ukuthi kulama magnet esosebenzisa ukuthi are these magnets strong or weak, right? So let's say we have weak magnets. Let's say lama magnet lawa weak, north and a south pole, right? It means in between kunama magnetic field, but strength sakhona si weak, ne? But then if we have a strong magnet, then it means our magnetic field, or the strength of the magnetic field si high, ne? But si representa njani in terms of ama line. It means lana kuzoba nama lines amaningi la, concentration alama line izoba iningi kakhulu because we are using a strong magnet. Therefore the magnetic field strength now is over strong, or the strength sakhona izoba high, right? But see, the magnetic field strength representa njani in terms of physics. Magnetic field strength siubiza ngo B, right? And ama units akhona ale magnetic field strength is Tesla, right? In short, just to T. So maybe in the first example last 7 sakhona weak magnet, maybe singathi strength sakhona is 0.2 Tesla ile magnetic field strength sakhona, right? But since last 7 sama magnet are strong, it means the magnetic field strength sakhona is over high, maybe 0.8 Tesla, right? So yakhona ukubona la ukuthi okay, nasebenzise magnet e weak, magnetic field strength yakhona nayo injani low, right? And if sisebenzisa ama magnet lawa strong, magnetic field strength yakhona low B uba high, and ama units akhona u Tesla, right? Okay, all right. So now I set up yokuqala la, let's assume sithatha ama magnet are strong, right? And siyazi ukuthi since sinama magnet are strong, maybe let's use our magnetic field strength to be 0.90 kule example yethu, right? So sesiyazi ukuthi okay, sebenzisa ama magnet are strong kangakanani, sesiyazi i magnetic field strength sakhona. So manje sizothatha i-coil. So i-coil inteka so, right? And i-coil ungayenza ibe square, ibe rectangle, ibe circular kanje, right? Okay, so le coil le kuze sibe ne-EMF high, ama number of turns kule coil mele abe high, right? Or mele abe maningi kahle kahle. So it means ngizothatha intambo ngenze i-coil kanje, ngiphinde futhi enye ngaphezulu, enye ngaphezulu kanjalo kanjalo. So the number of turns mele abe maningi. right? So that EMF yethu lesiyiproducer izoba yiningi. Okay, so sizothatha i-coil bese le coil le siyifaka lapha phakathi nendawo la kulama magnetic field. So in this case ngizosebenzisa le rectangle or square for illustrator le example, right? So ngizothatha le coil le ngiyifake la phakathi. So nase ngithathe le coil ngizospecify ukuthi ama number of turns ayingakhi, right? Ukuthi ngiphinda phindeka ingakhi le ntambo le, right? So i-coil naso ibuka emasayidini kuba into eka so if maybe i-secure, right? But ngizospecify ukuthi ama number of coils ayingakhi lapho. Let's say sisebenzisa 20 turns or let's say 200 turns kule example yethu. Siyayifaka i-coil lana ina 200 turns la phakathi, right? So ilo n wethu ke lo. It means ama number of turns it's 200. But sithe sisebenzisa ama magnet north and south and the magnetic field strength yakhona sithe 0.90, and the magnetic field strength izohlala constant because lama magnet angithi asiwashinji. Therefore throughout the experiment or throughout the process the magnetic field strength izohlezi in 0.9 Tesla, right? Okay, so the moment ngifaka le coil inside the magnetic field, then there is what we call a magnetic flux linkage or just a magnetic flux. So magnetic flux linkage or a magnetic flux is induced. Why sisho kanjalo? So kule case ngalesikhathi singanayo le coil la phakathi, there was no flux because there was no coil inside the magnetic field, right? But the moment sifaka le coil inside, then there is a flux which is linked to this coil. So that is why city magnetic flux linkage, it is linked with that coil, right? And lento le iba khona only when le coil iphakathi kwalama magnet or le coil lena iphakathi kwama magnetic field. Okay, so this magnetic flux is represented a symbol phi, right? And by calculation magnetic flux is equal to B, and UB wakho, remember UB would depend on lama magnets angisho, which is the magnetic field strength times the area, right? Lena area yan le, this is the area of the coil. Okay, so this is the area of the coil. So now in a square, remember this is a multiply lama side by 2 now, that is our area. If it's a rectangle, multiply lama side by 2, that is our area. But if it's circular, then it means we need a radius la pi area is with pi r squared, right? Okay, so that is the area of the coil. And then cos theta. So the angle there, it's between the magnetic field, right? So from north to south, and the normal of the coil, the 90 degrees of the coil, right? Okay, maybe logo so explain in terms of a video is born a rotate and then so let's check my angle corner lapho ne, so simulate. But in the meantime, as this angle is between the normal of the coil and the magnetic field, right? But in most cases, like angle lena, it is specified, or bangakubuza ukuthi uyi-calculate if you're given a magnetic flux, right? So it's nothing confusing there. Okay, we have the magnetic flux linkage. The moment sifaka the coil inside the magnetic field, right? Nice setup yethu la. So umbuzo uthi sesutholile ugesi now. The answer is no, not yet. But suthola na kwenze njani ugesi? Suthola le coil lena seqala i-rotator lana, seqala i-move la phakathi, right? That is when an EMF is induced. So i-setup yet it is nama magnet I2, right? And why seven sama magnet? So that we can have a magnetic field strength, or is induce a magnetic field, right? Bese sifaka i-coil lapha phakathi. Why sifaka i-coil? And i-coil nasifaka izoba nama number of turns lawa specified with C10 angle, right? Why sifaka? It's because we want to induce this magnetic flux linkage with that coil, right? Okay, so ugesi so produce kanjani la? The moment we turn the coil, so now turn the coil, le angle le, this theta yaqala yashintsha ke manje, right? And i-theta nayishintsha nale magnetic flux yashintsha, then that is when sithola ugesi. So it means kuze sithole lo gesi, this angle changes, right? And when the angle changes, nale phi, it also changes, right? So that is when we can get ugesi wethu, or that is when we can get electricity. We get electricity when there is a change in magnetic flux linkage. So for us to have electricity, this thing must change, right? So if bakubuza wena bathi sifaka i-coil phakathi kwama-magnets sayi-rotate, ne? Bese bathi give a reason why EMF it was induced. It is because there was a change in the magnetic flux linkage. There was a change in the magnetic flux linkage. That is the reason. All right, so asenze example let's calculate khona magnetic flux, right? Let's say a coil is rotated. It's rotated inside a magnetic field, right, of 0.5 Tesla. So lo 0.5 Tesla usitshela ini kahle kahle? Usitshela the strength of the magnetic field. Usitshela the strength of the magnetic field, which is UP weight, right, from analysis. So it is turned from 0 degrees to 45 degrees. Okay, so lana basitshela ama angle I2. Okay, fine. Bese bathi the area of the circular coil. So in this case basebenzise le coil le SQ, right? And basitshelile i-area khona, so azange basitshele nge-diameter. If basitshele nge-diameter bekuzomele siyi-calculate le area, but kule example le sithi basinikeza i-area is 5 meters squared. Okay, all right, fine. As you calculate the change in magnetic flux linkage. Okay, so kahle the siyazi ukuthi magnetic flux is equals to BA cos theta, angisho. But what about the change? Izothi final magnetic flux minus initial magnetic flux. So it means if final izoba na yipi angle, if final izoba na 45 degrees, initial izoba na na 0 degrees, right? So the change in magnetic flux linkage is equal to B area cos theta, the final, ne? Minus B A cos theta initial, okay? And then substitution, B CTL 0.5, right? That is our magnetic field strength, 0.5. And then the area is given as 5. And then cos of, what is the final angle? 45 degrees minus B 0.5, A 5, and then cos 0. Okay, so now let's calculator is at 0.5 times 5 times cos of 45 minus 0.5 times 5 times cos 0, which is 1, eh? Okay, and then the answer here to the C2 is negative 0.732, right? And the units webers. Okay, maybe ngikhohle mention la phezulu, the units of magnetic flux linkage is webers, WB. Okay, so that EMF is induced because there is a change in the magnetic flux linkage. All right, fine. So the EMF which is induced, how do we calculate that EMF which is induced? The EMF E, which is induced according to Faraday's law, is equal to negative. So why sifaka negative lap? It is because the current or the EMF which is induced, right? Okay, let's say the current that is produced, it is opposite to this change in magnetic flux linkage. So that is why sifaka negative lap. It is because the current which is induced, it opposes this change in magnetic flux linkage, right? So that is why sifaka negative. Okay, and then N is the number of turns, right? And kule example yethu sithe sifake i-coil ena 200 turns, right? So ilo N wakho ke lo. Okay, and then change in magnetic flux linkage, ilento lesiyicalculate la, right? Divided by delta T. So kahle this is Faraday's law, right? And now check out this N, it's just a factor, or it's a number, it's just a number specify ukuthi ayingaka ama turns lapha kule coil, right? And then naso check out the relationship le ela. This is the rate, because kunani lana kunesikhathi. This is the rate of change of the magnetic flux linkage, right? So it means this EMF, if loku kuyakhula, if this rate of change of the magnetic flux linkage iyakhula, it means nale EMF yakho izokhula. If kuya decrease, nale EMF yakho iya decrease. So these two are directly proportional, right? And angeke sikhuluma ngama number of turns in terms of the relationship. Fine, lena ya increase, nalo kuzo increase, right? Because that is one of the ways of increasing the EMF which is induced. So this is Faraday's law. So what is Faraday's law? It states that the magnitude, sikhuluma ngale magnitude yale EMF angisho, the magnitude of the EMF induced, okay, is directly proportional. It's directly proportional to the rate. Why is it rate? It's because it's not delta T of change rate of change of the magnetic flux linkage, because kushintsha le flux linkage kahle kahle la this thing. If lento le ishintsha fast, because remember nasibuya la phezulu sithe why is an EMF induced? It is because there is a change in magnetic flux linkage. Angisho, that is why. And if the magnetic flux linkage ishintsha fast, it means na le EMF esiyithola is over high. But if ishintsha slow, the EMF esiyithola is over low, right? So kahle the magnitude of this EMF which is induced, it is highly dependent on the rate of change of the magnetic flux linkage, and that is Faraday's law. It states that the magnitude of the EMF induced is directly proportional to the rate of change of the magnetic flux linkage, right? So now let's explain the terms now. This is the EMF that we're calculating, right? Or what we're trying to achieve, and this is the number of turns. This is the number of turns, and then this is the change in magnetic flux linkage. Back to okay, fine. See, change from this angle to this angle, then see apply the knowledge le 70 right? Okay, and then delta t, it is the time. Back to the magnetic flux linkage ishintsha from this to that, right? Okay, so as we look back to the example le, continue now. As it, a coil is rotated inside a magnetic field of 0.5, right? It is turned from 0 to 45 degrees, and the area of the coil is 5 meters squared, right? Number one, calculate the magnetic, the change in the magnetic flux linkage. As it number two, calculate the EMF if 200 turns are used, and the coil was rotated in 0.2 seconds. So necessarily 0.2 seconds, then this is our delta t, right? And this is our n, right? So calculate the EMF induced. EMF is equal to negative n change in magnetic flux linkage divided by delta t. This is Faraday's law. EMF is equal to negative 200, because it's 200 turns, and then a change in the magnetic flux linkage. Lapis is to negative 0.732. Negative 0.732, and then divided by delta t, it's 0.2, and that is the magnitude of the EMF which is induced. So that would be negative 200 times negative 0.732, and then all divided by 0.2, and totality, this is 732 volts. That is our EMF which is induced, right? So this is how we produce electricity using the concept of Faraday's law. Sibanama magnet I2. Why sibanama magnet I2? It's because we want to induce the magnetic field lapha. Then we can get our magnetic field strength, which is B, right? Measured in Tesla. Okay, and then since it's not a magnet, then it means we have a magnetic field. Then we can insert our coil inside our parat, and when we insert our coil, there is a magnetic flux linkage, right? But the moment you turn that coil, there is a change in that magnetic flux linkage. Then we can produce that EMF, right? And that EMF is directly proportional to the rate of change of the magnetic flux linkage. So that is Faraday's law.